Okay, we want to look at activity 2. It tells us that the concentration of a drug in the body, Cp, can be modeled by the equation that we see, where dg is the dosage administered in milligrams, vd is the volume of distribution, Ka is the absorption rate constant, Ke is the elimination rate constant, and T is the time in hours. Says the drug time in hours since the drug was administered. And for a certain drug, the following quantities are given. So we've been given some of the parameters in the question. And it goes on to say that a single dose is administered at t is equal to 0. Calculate and plot Cp versus T for 10 hours. Label the axis and provide a suitable title for the graph. So we have this expression we want to plot against T. We also want to find the value of Cp at T is equal to 10 hours. So let's work this bit by bit. We can start with the values they gave us. So we're given dg, that was 150. We're given vd, that was 50. We're given ka, that was 1.6, and we're given ke, which was 0.4. Now the expression we have here, we can decide that we want to do it the symbolic way, or we can decide that we want to do it the normal way, right? So if it's the normal way, I can just type out the expression. So Cp is equal to dg over vd times ka over ka minus ke, all of this times exponential minus ke times t, and then times t, then minus exponential minus ka times t. So that's what we are going to get. So I can suppress that. Now we know the interval that we are plotting t across it, so we can see that maybe my t span is from 0, because I said from time 0 at time 0. I want to calculate it up to time 10, so 0 to 10. Okay, so if I should just type plot, maybe think CP against t, so t is on the x-axis, so I'll type the t span comma Cp. Oh no, sorry, I'm supposed to use the value of t here. So because I put t in the equation, I'm supposed to use t here. So sorry about that. So this is t, right? So I'll do it this way. So if I should plot this, I'll be getting this graph, right? If I want the graph to be smoother, I can increase, or I can specify the increment. So from 0 to 10, but I want it to increase by 0.1. So if I should do it this way, it would make the graph a bit smoother for me. Now, we're also told that we should label the axis and provide a suitable title for the graph. So I can say x label, so this will be for the x-axis. I can type time in hours. I can say y label, then into brackets my inverted commas, and I can type maybe concentration in milligram per liter, and then I can say for the title maybe drug concentration profile or something, right? So I can do this as well. So if I should run it this time, would have the axis and the title coming in. Now the question also said that we should calculate for Cp at 10. We are not just plotting the Cp, we're also calculating Cp at t is equal to 10. So I can type, so I can, if I want to do that, right, I can decide that, okay, maybe let me recopy this. So I'll go through another process, but realize at this point, okay, let me do it this way. I think let me rather display the Cp and the t values we have. So let me display Cp against the t's. Okay, so for t being equal to 10, that is in the very last column, that's 101. So if I look for the corresponding CP, that should also be the very last value, so 0.0733. That should be our corresponding CP, right? Or I could have decided that my expression for CP, I replace the t with 10. So maybe I can say that I want to find, I can make this maybe a different value, CP1. So let me type that down here. So maybe I can put the expression for CP here, make this CP1, and then instead of t, I'll make it T1. Then I'll say that maybe T1 is equal to 10. So if I should run this, and I can just look for the value of CP1, it will give me just that value when it is equal to 10. I was saying that we could also use the symbolic function approach. So let's try that as well. So for that one, when I get to this point, right, after I specified all the initial terms, I can assume that I can work with the fact that this is a symbolic function in terms of t. I can type sims t. Oh, I shouldn't have cleared everything because I need the expression. I don't want to retype all of this. So let me copy the expression first before I clear everything because I don't want to retype the whole expression. Okay, so I can type sims t and then type my expression. Right, now when I'm done, I can also now include my intervals. Maybe my interval is from 0 to 10, and then I can type ez plot my cp, then my interval. So let me suppress the interval. So now if I should run this as well, I'm going to get a very similar graph, right? So I can label the axis and everything once again. But I realize the difference between using this and using the plot. When we use the ez plot, we made it 0 to 10. We just gave it the first and last value and it plotted everything. But when we use plot, we had to make it 0 is to 10. If we don't do it this way, what we are going to get is not going to work. So I'll show you what will happen if we don't do it this way. But let's look at what happens with the ez plots. If we do this with the ez plot, it will still work, right? So for the ez plot, you can decide to bring the colon or you can decide not to, and it will be fine. But if it was the earlier case, let me take it back to when we used plot. And now instead of me saying 0 to 10, let me just say 0 and 10. What it will do is that it will plot just the first and then the last point. So we'll end up getting, oh, I'm coming. Okay, the CPA expression, I deleted it. Sorry, let me put it back in there. I think I deleted the CPA expression. Okay, so let's try that again. Let's say now I'm getting a straight line y. Just plotting the first value, that's at 0, and the last value at 10 and joining them. So if I want to get something very accurate with plots, it's better I use the colon to indicate that it's not just plotting at 0 and 10, but it's plotting from 0 to 10. So please take note of that. If you are using plots, the colon has to come. If you are using ez plot, it's not really an issue, right? So just take note of that.